Welcome back, Pre-Algebra. We're in Lesson 19. For just a moment, let's review the symbols of multiplication. So we know 4 times 3. We can write that like this. We can also write multiplication like this, 4 times 3. And a lot of times we switch from the x to the dot because we've begun using variables. And a common variable that we use is x. So we don't want to confuse an x with a multiplication symbol, and that's why we use the dot. Another way that we can prevent multiplying or treating the multiplication symbol like an x or vice versa is to use parentheses. So we can write 4 times 3 just like that as well. But we can also put the 4 in parentheses and it would look like that. And that also is 4 times 3. So those are your different symbols for multiplication that you can use, and they all mean exactly the same thing. So put that in your notes. You're going to want to remember whenever you see the parenthesis that it is multiplication. Whenever you see the dot that it is multiplication, okay? All right, so let's jump into our lesson. We're going to multiply some fractions, some more fun multiplication. So let's start with the first problem. 4 over 9 times 5 over 7. 4 times 5 is 20, and 9 times 3 is 63. And there is not a common number that we can reduce these by. The factors of 20 are 2, 2, and 5, and the factors of 63 are 3, 3, and 7. So there's nothing that we can combine to be able to divide both the top and the bottom of the fraction to reduce. So let's go to 19.2 and see how that looks. So in 19.2, we're asked to simplify 2/3 to the third power. So we know when we see an exponent that that is simply asking us to multiply this number 3 times. And whenever you have an exponent that's on the outside of the parenthesis, it means to multiply everything within the parenthesis that many times. So that's what we're going to do. We're going to say 2 over 3 is one time, times 2 over 3 a second time, and 2 over 3 a third time. And now we just go straight across 2, 4, 8, 3, 9, 27. And that would be the answer to 19.2. We cannot reduce that at all because there are no common factors between the top and the bottom. So we see that neither 3/8, if the numerators and denominators contain common factors, it's helpful to simplify before multiplying. The terms of fractions may be reduced before they are multiplied. So let's look at an example of that. If I had 3 over 8 times 2 over 3, I could reduce that before I ever do the multiplication. And one way to reduce that, I see that I have a 3 on top and a 3 on the bottom. And I also know that 8 is actually 2 times 4. So I could reduce by taking the 2 out of the top and the 2 out of the bottom on that side. So this goes away too because that became 2 times 4. Now when you take everything off the top, we know that that leaves behind a 1. So the answer to this problem would be 1/4. But just to be sure, just to play it safe and do it the old way, I'll show you. If you have 3 over 8 times 2 over 3, that would be 6 over 24. If I divided the top by 6 and the bottom by 6, I would get 1/4. This way was just a little bit faster than this way. So the way that you want to do this is by finding a common factor for the top and bottom and eliminating it, or what we call canceling it before you complete any of the multiplication. So let's go ahead and do that with example problem 19.3. Let me switch back to this one because it shows up better. In 19.3, we are asked to simplify 4 over 9 times 18 over 30. Now, because this is all multiplication, we can just draw one line and multiply straight across. So 4 would become 2 times 2, and that's being multiplied against 18. And 18 is 2 times 9. Now on the bottom we have 9, so I already see that common right here, so I'm just going to leave it the way it is because I know I can cancel those out. And that's being multiplied against 30, and 30 is 2 times 15. Now you could go ahead and break that down into 3 times 5 if you wanted to, but there's not a 3 and there's not a 5 up here. So you would end up just multiplying it back together anyway. So now I am going to cancel. I'm going to use my red pen, and I'm going to cancel this first 2 against this 2, and I'm going to cancel this 9 against this 9. So what I have left is 2 times 2, which is 4, and 15. And that is it. So my reduced answer is 4 over 15 for this problem. So that is completely reduced. I didn't have to multiply the big numbers and then turn around and divide them. I was able to do it all in one step. So we have put together some things that we've learned. We've put together both prime factorization and canceling or division in order to save time in the long run. So to divide, actually it means it's the reciprocal of multiplication. And so division technically is multiplying by the divisor by the quotient. That is the inverse operation. For instance, when we have 4 and we divide it by 2, the answer is 2, right? 2 times 2 is 4. So that shows us how they work together. Multiplication and division are opposites of each other. So when we want to divide fractions, it makes sense that we can use the opposite operation if we do some reciprocal or inversion of the fractions. So let me give you an example here. If I had 1/2 and I needed to divide that by 2, I know that if I were to cut 1/2 into 2 pieces, I would have 1/4 and 1/4, right? Because those would add together to make 1/2. Let me illustrate it with a circle here, right? So here is 1/2. And if I were to divide this 1/2, I'm going to shade it in. This is the side that I'm working with here. Right? If I were to divide this half into 2 pieces, I would get quarters. I would get 1/4 and 1/4. That makes perfect sense. You can see that. So how do I get there mathematically? Well, knowing that multiplication is the inverse operation, we can employ a tactic called keep it, change it, and flip it. And that's what we're going to do. I'm going to let you see what those things mean. So what we're going to do first is we're going to keep the same fraction. All right, keep it. We keep the same fraction. Change it means we change the operation from division to multiplication. And flip it means we're going to use the inverse fraction. So we know we can make a whole number a fraction by putting it over 1. So when I flip it around, that becomes 1 over 2 instead of 2 over 1. Now, when I do the multiplication, 1 times 1 is 1, and 2 times 2 is 4. And that is the answer we were looking for, 1/4. So that is our proof to see that keep it, change it, flip it does work. Let's try another example just to be sure. All right. Let's say we want to divide 1/2. Let's divide it by 3 this time, right? Whole different set. Here's my circle again, and I'm going to cut it in half. Here's my half. I want to divide that into 3 pieces, right? 1, 2, 3. That's 3 pieces. Well, I know that of the whole, this would be, well, my drawing's not very good, is it? If I can get it to do right. There we go. All right, so if I wanted to cut that into 3 pieces, I would have to do something like this. We'll just pretend that they're equal pieces. So what that means is my 1/2 now contains 3 sixes, which is the same thing as 1/2, right? But it's 3 sixths. So one of these would be 1 over 6. Right? 1 over 6, 1 over 6. But my 1/2 is 3 of them. I'm dividing it into 3 pieces, so the one little piece that I'm worried about would become 1/6. Mathematically, let's make sure that that works out. 1/2, we're going to keep that part. We're going to change the division to multiplication, and I'm going to turn that into a fraction, and I'm going to flip it. So keep it, change it, flip it. Now that becomes 1 over 3 instead of 3 over 1. And 1 times 1 is 1. 2 times 3 is 6. Again, that gives us the answer that we were looking for right here. 1/2 divided into 3 pieces, that is 1/6. So we've seen twice that the math holds true. It stands up. So let's see if we can do a problem using that. Let's do 19.4. So we are asked to simplify 21 over 6 divided by 27 over 4. So we're going to use more than one technique here. We are going to, first of all, do keep it, change it, flip it, so that we can make this easier to solve, right? So 21 over 6, that's the keep part. Change is turning it into multiplication, and flipping it puts the 4 over the 27. But now I don't want to multiply 21 times 4 or 6 times 27. Those are kind of going to be big numbers. So let's see if I can put this into prime factorization and cancel something so I don't have to do the hard stuff. So I know 21 is 3 times 7. And I know that 4 is 2 times 2, right? All right, well, let me make this 7 a little bit clearer. There we go. 6 is going to be 3 times 2. And 27 is going to be 3 times 9. All right, so let's look and see what we can cancel. So I see right away I can get rid of a 3, and I can get rid of one of those 2's. And that's all I can do, because there's not a 7 down here, and there's not a 2 down here, and there's not a 3 or a 9 up here. So my answer is going to be 7 times 2, which is 14, over 3 times 9, which is 27. And that's pretty awesome that we were able to do that without having to go all the way up to that big number and come all the way back down. It's just so much easier. All right, that is all that we have for lesson 19. So I will see you in lesson 20.